Hello everyone. In this video, we are going to talk about the Newton backward interpolation method. So this is one of the numerical method, or you can say a interpolation method to find a particular value of the y for a given value of the x. So we have seen in the previous video about the Newton forward interpolation method, which is another interpolation method. Okay, and both these methods, Newton forward and Newton backward, are used to find the interpolated value in case of the equal intervals. So if you have not seen the Newton forward interpolation method, then you can find the link of that method in the numerical method playlist, and you can find the link of the numerical method playlist in the video description below. So there is just a small difference in the formula of Newton backward interpolation method. Otherwise, this method is similar to the Newton forward interpolation method. So in this video, first we will be taking a working example to understand this method, and after that we will see the algorithm and the C program implementation for this Newton backward interpolation method. So let's start. Although I have discussed in the Newton forward interpolation method that why we are using the interpolation method, or what is the meaning or significance of this interpolation. So just to recall, so let's say we are given some values of the x, 3, 5, 7, 9, 11, okay? And the corresponding values of the y are 16, 20, 24, and so on, okay? Now, the difference between these x values is actually equal. That means the difference between 3 and 5 is 2. The difference between 5 and 7, it is also 2. 7 and 9, it is 2. And difference between 9 and 11, it is also 2. So all these values of x, they are equally spaced, or they are having the equal interval gap, right? So Newton forward and Newton backward can only be applied if all these x values, they are equally spaced, okay? Now interpolation means that we have to find some particular value of the y at some given value of the x. So let's say we are asked that if we are given the value of x as 10, then what will be the corresponding value of the y, okay? So this is meant by the interpolation, okay? And now there are different methods depending on whether we are finding the value of y something in the starting or in the middle or at the end, okay? So for example, we can have x equal to 3.4. That means we can have x in the starting of this table, or we can have let x equal to 9.8. That means 9.8 will come at the end, right? Now we can have x in between, for example 5.7, 7.6. so it will be somewhat here, okay, or somewhat here. So the x value can lie in the starting or in the end or in the middle. Depending on where the x value are lying, we have different formulas. So if the x value for which y value is being asked, that x value is in the starting of the table, then we are using the Newton forward interpolation method. If x is at the end, then we will use Newton backward interpolation. Otherwise, we will use central difference interpolation formula. And we have different central difference interpolation formulas. Like these are these different formulas. Okay. So in this video, we are going to talk about that how this Newton backward interpolation method will work. That means if we are asked some corresponding value of the y at a given value of x, and that x value is lying at the end of the table. Okay. Now, as I told you that Newton backward method is a numerical method, so it will give me the approximate value, okay? Second thing is I can use the Newton forward and the central difference formula also if we want to compute the value of the y for the value of x, which is equal to 9.8. that is the x value is lying at the end of the table. But in that case, Newton forward and the central difference formula will not give me that much accurate value, which I can get by the Newton backward interpolation method, okay? So you have to see which type of x value is given to you. Either it is in the starting or in the middle or at the end. Accordingly, you can use the different formula to get the accurate, or you can say the nearby correct values, okay? So let's study Newton backward interpolation method with the help of a working example. So here is our question. So we are given this table and we are given some values of the x and some values of the y. So we are having some years as the value of x, 1891, 1901, and so on. And in each of the year, the population is given. For example, in the year 1891, we are having the population as 46, okay? And you have to note that this population is given in thousands. So that means in year 1891, the population is 46,000, okay? And in 1901, the population is 66,000, and so on. Now, we are asked that if we want to find the population in the year 1925. That means 1925 will lie between 1921 and 1931. That is at the end of the table. So what will be the value of the y? That means what will be the population in the year 1925? Okay. Now, as 1925 is at the end of the table, so we will be using Newton backward interpolation method. And this question is same as what we have discussed in Newton forward interpolation method. In that question, we have find the population value in the starting value of the x. Okay. So by this table, we can also get a clue that as this population is increasing, 46, then 66, 81, 93, then 101. So for the year 1925, we will be getting the population in between 93 and 101. Okay. So let's see. So to apply this Newton backward interpolation method, we will formulate our values of the x and y in the table. So here you can see these x value corresponding to the years and y value corresponding to the population. Okay. So this y value can also be written as the function value or the f of x, right? Now, the first step in Newton backward interpolation method is we have to create a difference table. Okay. And let me tell you, the difference table in case of backward method is same as what we have seen in the Newton forward interpolation method. Okay. So if you have seen my Newton forward interpolation video, so you will find very easy to construct the table in this video. Okay. So here is our difference table, which is similar to what we have seen in Newton forward interpolation method. So here we can see these are the x values and these are the y values. Now using y values, we will be finding all these values that you are seeing in this red color, right? Now these difference are written as del y, del square y, del cube y, and del 4y. Okay. So in forward interpolation method, we have seen that this symbol was something like this one. Okay. Del square y. Okay. But in backward interpolation, we are just inverting this symbol, del of y, then again del square y, but this del is just inverted. Okay. Otherwise, there is no such difference. Now, this is the first difference. Now, how we are finding these values 20, 15, 12, and 8? So this is again same as the forward interpolation method. So what we have done is we have subtracted 66 minus 46. That means this 20 is equal to 66 minus 46. Now again 81 minus 66, it will be 15. Then 93 minus 81, the difference is 12. So we have written here. Now 101 minus 93, it will be 8. Now after finding this first difference, we will be finding the next difference, that is del square of y. Now again del square y is constructed on the basis of these values of del of y, that is 20, 15, 12, 8. So now we will be using this column to construct this del square y. So we will be subtracting 15 minus 20, that is 15 minus 20, it is minus 5. Do not do this thing like 20 minus 15. Okay, then that will be a positive value and that will be a wrong value. Okay, now 12 minus 15, it will be minus 3. 8 minus 12, it will be minus 4. Okay, similarly we are constructing this del cube y values. Okay, this is minus 3 minus of minus 5, this is 2. Then after subtracting minus 4 minus of minus 3, we are getting minus 1. Okay, and lastly this column value is like this minus this, that is minus 1 of minus of 2. Okay, so this is minus 3. So this way we have constructed the difference table. Okay, now the difference between the forward and backward is in the formula. Okay, so let's see how we will be applying the backward interpolation method formula. So this is our formula for the Newton backward interpolation method. So here you can see we have the f of a plus hu equal to f of a plus u multiplied del of f of a plus u plus 1 upon 2 factorial del square f of a and so on. Okay, now what is this a plus hu? So as we have seen in the Newton forward interpolation method, this a plus hu is the x value corresponding to which we have to find the value of the y. So in this question, as we have seen that we have to find the value of the y at x equal to 1925, right? So this a plus hu is actually 1925. Okay, and what is this a and what is this u? So to find this value of the u, we can see that we have a plus hu, as I have told you, it is equal to 1925, right? Now what is this a? So in case of the Newton forward interpolation method, this a was actually this starting value 1891. But in case of the Newton backward interpolation method, this A will be the last value of the X, that is 1931 in the table. Okay, so this A, it is 1931. Now what is this H? So this H is the interval gap. So what is the interval gap? Interval gap means the difference between the X values. So the difference between 1891 and 1901 is of 10, right? The gap between these two values is also 10. If we subtract this, then also we will get 10. And difference between 1921 and 1931 is again 10. So all these X value, these are actually equally spaced, right? So we have to, so this H is equal to 10. Okay, so this is the interval gap. Okay, now you have to take care that you have to take just the gap value, that is it will be a positive value. We are not taking the sign value. Okay, so now we can find the value of the U. So your U will be equal to 1925 minus of this A value upon this H. Okay, and if we put A equal to 1931, we are getting U value as minus of 0.6. Okay, so this way we can find the value of U using all these values. Okay, so we can put all these values of the various parameters in this given formula, and we can find the population at f of 1925, right? So f of 1925 can be written as, for example, y of 1925. So I will be using this convention. Okay, now similarly this can be written as y of A. Okay, so this can be written as y of 1931, right? Because A is 1931. Similarly, this can be written as del of y. Now, what is this A? So this is 1931. So this means this del y 1931 is actually, we are talking about this column. Okay, and what is this value? So this is actually del square y of 1931. Similarly, we can write this also. Okay, so in Newton backward interpolation method, we will be taking the last values. So last values means we will be taking 8, minus 4, minus 1 and minus 3. Okay, to put in our this formula. In Newton forward, we were taking the upper values. Upper values means 20, minus 5, 2 and minus 3. Okay, so here we are written as that f of A. So f of A is simply y of 1931. Okay, so this is actually 1931 and this is can be called as y of 1931, that is function value at 1931, right? Now this del of y of 1931 is actually this value. Okay, this is 8. Similarly, del square y 1931 is, del square y is this column, and del square y 1931 is the this last value, that is minus 4. Okay, and similarly del cube f of A will be this value minus 1. Okay, and similarly we will be using the next value also, del 4 of f of A. So that will be this del 4 and this is del 4 1931. Okay, so this way we will putting all these value in the formula. So here I have rewritten our formula, that is we have to find the y value at 1925. Okay, and here this is our difference table. So let me put all the values. So here y 1931 is this one. Then the value of U we have found as minus of 0.6 and this value is this 8. Similarly, we are finding this u plus 1 upon 2 factorial. So this is u, and u plus 1, this is 0.4, that is u is minus of 0.6 plus 1. So this will be 0.4 upon 2 factorial. Then this is actually minus 4. Similarly, we have put the u value here and we got this thing, then into this minus 1. Okay. Similarly, we put u value in this thing, we got this, and the last value of del 4 y 1931. So del 4 of y 1931 is the last value minus 3. Okay, so after solving this thing, we got 96.8368. Okay, and all the values of the population, they are in 1000, so we are specifying 1000. So corresponding to year 1921, we have this much of population. Okay, so this population 96.8368, this is between 93 and 101. Okay, as I have told you in the beginning of the video. Okay, so I hope you have understood that how this backward interpolation method is working. This is similar to the Newton forward interpolation method. Only the difference is in the formula. here you have to take care that here we are using the plus, okay. In the Newton forward, we were using the minus sign here, okay. And we have to take the last values, okay. We do not have to take the starting value. Starting value were taken in the Newton forward interpolation method. So these are the two differences in the Newton backward interpolation method, okay. The difference table is same way constructed as in the case of the Newton forward interpolation method. So now let's move to the algorithm. So this is the algorithm. So algorithm says first we have to ask the user that how many values of the x or the number of observations that you want to enter. So we will be given these x and y values, right? So how many these data points are given to us? So these are total 5 data points. This is first, second, third, fourth, fifth. So in this example, n will be 5. Next, we will be asking the user the values of the x, okay. So these are the values of the x, okay, and these are the values of the y. So now we will be actually taking a matrix to store all these values of the x and y. Y matrix, you can take simple 1D array also, but I am using a matrix because here in this zeroth column, let's say this is the zeroth column of the matrix. This is the first column of the matrix. This is the second, third, fourth, and so on. So in the zeroth column, I will be saving all these values of the x. In the first column, I will be taking all the values of the y. In the second column, I will be calculating the difference, okay. Here I will be calculating the next difference, right? The same way I will be storing all the differences in the various columns in this matrix, okay. So matrix will club together all these values of the differences in just single table, okay. Now what will be the size of the matrix? Although you can take a very big matrix also, but it will be a wastage of the memory, okay. So to save our memory space, we will be taking only the memory space that is useful to us, okay. So here you can see we are having how many observation? N equal to 5 observation. So as we have seen in our difference table, we were calculating this del cube of y and last was del 4 of y, okay. So how many rows are there? So rows will be actually 5, and how many columns will be there? So columns will be there 1 2 3 4 5 6, right? So if you see, let's say if we are having n equal to 4, then there will be how many rows? There will be 4 rows. And how many columns? Then there will be actually 5 columns, okay. So you can see that for n equal to 4, this row number is equal to n, and this column is equal to n plus 1. Similarly, for n equal to 5, this is equal to n, and this is n plus 1. That's why I'm taking the size of the matrix as n plus 1, okay. Now, after that, you will ask the user that what is the value of x for which you want to find the value of y. So in our case, our x is 1925, okay. Now after that, we will just create the difference table. We will apply the formula, and before applying the formula, we can just find the value of the u, okay. And after applying the formula, we can find the value of the y, okay. So this is a simple algorithm, okay. So let's see how we will write the pseudocode for it. So first thing, as we have to enter these values of the x and these values of the y in our matrix, okay. So this is the zeroth column, this is the first, okay, and this is the row number 0 1 2 3 and 4, right? So these loops are same as we have seen in our Newton forward interpolation method, because value will be entered in the same way, okay. There is no as such difference. These values are like 0th row, 0th column, 0th row, first column, 0th row, second, and so on, okay. So the column is not changing, only the rows are changing, right? So here you can see only the row number is changing from I equal to 0 to this 4. So I is less than n, and the column is not changing. So this will be 0 0, then again it will be like 0 1, then 0 2. So all the values will be scanned. Now similarly, y value will be scanned. So y value will come in the first column, right? And the row number are again changing. So row number are changing from I equal to 0 to less than n, that is n minus 1. And the column is not changing, okay. Column will be first column. So this way we have scanned the values of the x and the value of the these y's, right? Now let's create the difference table. So here is our code for the difference table. So this code is exactly similar what we have seen in the Newton forward interpolation method, and this is our table. So here you can see I have taken 2 loops. This is the outer loop and this is the inner loop, okay. So here you can see this is like 0, 1, 2, 3, 4, 5, and these are the rows 0, 1, and so on. So how actually we will proceed? So first we will find this difference. Okay, we will be subtracting 66 minus 46, 81 minus this minus this, and we will be getting all these values. Okay, so all these values for a particular column will be found by this inner loop. Now after this inner loop is over, after finding all these values, I will be moving to the next column to find all these values. So the next column will be traced by this outer loop. Okay, so that means this j will be tracing are the next columns. Okay, for example, initially j will be 2, that means I am will be at this column. J will be 3, I will be at this column, and so on. And for all the jth values, I will be coming inside this and I will be calculating all these values. Okay, so here you can see we have to find the difference. Right now let's see how it will work. So for j equal to 2, that is I want to find all these differences and I want to fill in the jth column. So I am starting from the j equal to 2. Okay, and you can see this j is less than n plus 1. So for n equal to 5, for this example, this is 5 plus 1, 6, j less than 6. So it will run for j equal to 2, 3, 4, and 5. That is 4 times it will be finding the differences 1, 2, 3, and 4 for the 4 column, right? And you can see this inner loop is actually dependent on the jth value, right? So actually the thing is, in each of the column the values are changing. That is, in the first difference column we are finding 4 values, in the next column we are finding 3, then 2 values, then 1 values, right? So I'm saying, okay, change this limit every time depending on the jth values. For example, if j equal to 2, this will be 5 minus 2 plus 1, so this will be 4. So this is actually the value of the, you can say, I less than 4. Now when j is 3, okay, when j is 3, so this will be 5 minus 3 plus 1, so this will be 3. In that case I will be running less than 3. That means I will run for I equal to 0, I equal to 1, I equal to 2. So I is actually this one, so I equal to 0, 1, 2. Okay, that means for this it will be running for only this number of times. And when this j was 2, that means for this column I will be running for, you can say, 0, 1, 2, and 3 less than 4. That means 0, 1, 2, 3 means for this number of times. Okay, so this way this loop is changing again and again. Now let's see how it will work. So let's start from j equal to 2. Okay, and now I will be running from I equal to 0 to this n minus j plus 1. So this n minus j plus 1 was 5 minus 2 plus 3 plus 4. Okay, so this is 4. Now here you can see I am doing this subtraction. So actually I need this 20 that will be stored here. Then I need 15, then 12, then 8. So how I will be getting this 20? 20 is the subtraction of 66 minus 46. Okay, so I have to take care I is here and j is here. And using this I and j value, I have to do the manipulations on this subscript to get my a of ij, that is 20, right? So actually I want to subtract a11, that is the 66, minus a of 01 minus a of 01. So let's see how. So here you can see I need 1. Okay, I need this row number and this column number. So row number currently is I equal to 0, but I need 1. So I will be saying I plus 1. Okay, so that I can get 1 from the 0. Okay, now this column is 1, but I am having j as 2. So I need one lesser column number. So I will be subtracting j minus 1. Okay, so I will be getting 1. Now I have to reach to this 46, that is 0, 1. So this 0 is similar to this thing. So I will be simply writing a of I. Now this 1 is again lesser than this 2. Okay, so I will be subtracting minus 1. I got this thing, 66 minus 46, 20, right? Now this loop will again run, and now I will be equal to this 1. Now for this I equal to 1, I need this 15 value, which is the subtraction of 81 and 66. So this is actually 2. Again, 2 is 1 greater than this I. So I plus 1. Okay, and this one is the like 1 lesser than this j equal to 2. So I am saying j minus 1. Okay, now this 1, 1 here you can see this one row number is actually same as I, so I'm simply writing I, and this column number 1 is again 1 lesser than this j equal to 2, so I'm saying j minus 1, j minus 1. So this way I am finding the subtraction of 81 minus 66, and I am storing in this aij. So here you can see that this is my aij. I am not saying something like ai plus 1 j minus something. Why? Because here you can see this is actually the row number 1, column number 2. Okay, so when I am finding this 15 by the subtraction of 81 66, my I is 1, j is 2, and this is simply 1 2. So this is corresponding to my I and j only, simply aij. Okay, so I'm not writing something else. Okay, so this way when this loop will get over after running from I equal to 0 1 2 and 3. Okay, 0 1 2 3, I will be coming out of this loop. Okay, and now I will be moving to the another column, that is j equal to 3, and for j equal to 3 column, my this value will be 3. Okay, so that means I will run for I equal to 0 1 2, okay, till this time. Okay, so here you can see I am finding only these values, right? So now I will be subtracting this 15 20 12 15 8 12, right? So here you can see I will be starting from 0 and j I am starting from 3. So I need these values. So this will be like 15, that is 1 comma 2 position, and this is like 0 comma 2. Okay, and this value will be 2 comma 2, and this will be 3 comma 2. Okay, so let's see for the last time that are we are getting the same values here. So here you can see I have to subtract 15 minus 20. So I should be subtracting 1 2 minus 0 2. Okay, a 1 2 minus a of 0 2, right? So here you can see my I is actually this 0. So I need 0 plus 1, that is 1. Okay, here I need 2, but my j is 3. So I am subtracting this j minus 1, right? Now here this is 0 2, right? So 0 is actually equal to this I. So I'm simply writing a of I, but this 2 is 1 lesser than this 3. So simply j minus 1. So I got 15 minus 20, and I'm storing here. This is like 0 position comma 3. So this is aij. This is aij. So this way this loop will run and it will find all these values, and in the next time it will find these values, it will find this value, and so on. Okay, so I hope you have got this code, that how it will work. Okay, so now let's move to the next part. So here is our formula. So here you can see the formula is this one that we have discussed, and this is the difference table. So in this formula we have to first find the value of the u that we have to put. So here you can see u is x minus, this is actually the value of the a, x minus a upon this is the value of the s, that is the interval gap. So x minus, now this value is actually n minus 1 0. So here you can see this is 0 1 2 3 4. Okay, and this is again 0 1 2 3 4 5, right? And for this example n was 5. Now we have to take a 1931 in place of here. So 1931 in terms of n, how it will be computed? So here you can see this is actually 4th row, 0th column. Okay, and n is 5. So this is actually a of n minus 1, but 0th column. So a n minus 1 0. So this will be telling me that this is 1931. Now upon this is the h value. So the value of h can be found by either subtracting this one, or this one, anything. So I have just simply subtracted 1901 minus 1891. So these are those things. Okay, a of 10 is 1901, and this is a00 1891. So I will be getting 10 from here. Okay, so x minus 1931. Okay, x is like in our example x was 1925. So 1925 minus 1931 divided by 10. Okay, so this way I have simply computed the value of u that I have to compute only for the first time, right? Now here you can see this is the application of our this formula. So what this formula is actually doing, this formula is starting from here. Okay, this is actually adding all these terms starting from here. This, the initial value y of 1931, that is 101. This I am saving here. So y is actually a of n minus 1 1. That means this is 101. A n minus 1 means this is 4, and this is the first column. So 4 comma 1, right? So this is 101. Okay, so my final answer will actually be getting saved inside this y only. Okay, so this is like I am adding this answer, then I am finding this total answer, okay, and adding with the previous answer, then I will be finding all this answer and I will be adding with this answer, okay. So this way I am computing all the values, right? Now in our code, let me tell you that this thing u plus 1, okay, this will be saved inside u1, okay. This thing, that is the factorial, it will be saved inside fact. After we have found the u1 and the fact value, then we will be multiplying u1, then this, and divided by this fact to store inside this y. So you can say u1 and this is aij is actually this one and fact is this one. So this will be like multiplied and divided, and then I will be adding with the previous y and I will be storing inside this y, okay. And then again this will be saved inside u1, this will be saved inside fact, and then all these value u1 fact and this value will be multiplied and divided and stored inside this y, okay. So this way this thing will go on. So let's see. So initially what I have done is inside u1 I am saving the value of u only, okay. So u was actually minus of 0.6, okay. So this is like u1 only, okay. Now initially fact is 1, so here you can see this is upon 1 factorial. So factorial of 1 is actually 1 only, so I am saving the initial value of fact as 1, okay. Now I am starting from j equal to 2, okay. So j equal to 2 corresponding to the column number, okay. Now again your implementation can be somewhat different from what I have shown here, okay. So this is okay. So for one question there can be many implementation coding wise, okay. So let's see. So here what I am doing is I'm starting from I equal to n minus 2, okay. So what I'm saying, this is actually n minus 2 because for our example n is 5, so 5 minus 2 is 3, okay. Because I am needing all these values 8, minus 4, minus 1 and minus 3. So I am starting from the back of the table, okay. So here you can see that I am running from this 3, 2, 1, 0, okay. So I am decrementing this I value again and again, okay. Now let's run for I equal to 3. So here you can see inside this loop I'm saying y equal to y plus. So initially this y is actually having this value, that is 101, that is this one, so 101. Now I am adding 101 plus this answer, okay. So this is the same thing. So u1 is actually this u, that is minus of 0.6 multiply aij. Aij is actually del of y 1931. So my I is actually 3, that is n minus 2. J is 2, okay. So this 8 is aij divided by fact is actually 1. So this is simply 1. So I am saying 101 plus this everything, okay. So whatever answer will come, it will saved inside this y, okay. So y is actually the sum of this thing, right? Now I am done with all these two terms. Now I will be moving with the preparation of the next terms, okay. So for the next term what I need u1, that is this thing. I need factorial, okay. So here you can see factorial will be, now this 2 factorial is actually the can be written as 2 multiply the previous one. So previous factorial was 1, so 2 multiply 1. So I'm saying the previous factorial multiply this j value, okay. So j value is currently 2, okay. So 2 multiply 1, 2, okay. So fact is 2. Now I have computed this. Now I have to compute u1. So u1 is actually, you can see u multiply u plus 1, okay. And here you can see this is u plus 1, u plus 2. So u plus 1 is actually the previous one value, this one value, okay. And again here you can see this part is actually this much only, and I'm just multiplying u plus 3. So I will be reusing the previous values of the u1, okay, to compute the next values of the u1, okay. So if I want to compute this u1, so this u will actually be the previous u1, okay. So the previous u1 is actually this thing, okay. And then I'm saying u plus 1, that is u plus, now this one I need. So I have to apply my own logic that how I can like compute this u plus 1. So I'm saying u plus, now I need 1. So actually j was 2, so I am saying j minus 1, okay. For my coding, okay. You can apply some different logic also. So this will be u1 multiply u plus, this will be 1, okay. So I have computed u1, this thing. So I have fact, I have u1, okay. Now I will be moving further. Now I will tell you why I am doing this j plus 1, okay, later. So Now I came here. Again, I have to find all these things. Okay, fact u1 multiply this. So I'm saying, okay, the previous values of the y plus u1 multiply this answer. So this answer is actually this one, right? So currently, what is the value of my I? So here you can see I have subtracted actually the I value, okay, before coming inside this loop, okay. So my I is now I equal to 2, okay. And here you can see I need J. Now, the value of J here is actually how much? It should be actually 2 and this should be 3. If I want to write ij, so I should need 2 comma 3. But if I do not increment this j, so previous j was 2 only, so I will be getting 2 comma 2. So 2 comma 2 is what? 2 comma 2 is this. That's why I am increasing the value of j so that I can come to this. So that's why in the previous iteration I said j plus 1. Okay. So now I will be getting minus 4 here divided by factorial. So previous factorial was 2 factorial. So 2 factorial. So this way all these three terms 1, 2, 3 they are getting saved inside this y. Okay. So this is over. Now I will come for the preparation of this thing. Okay. So I need u1 and fact. So now this fact 3 factorial can be written as 3 multiply previous thing. Previous thing was this thing 1 multiply 2. Okay, so 1 multiply 2 is actually saved inside the previous factorial and I need this 3. So I am simply saying j, okay, because j is my currently 3. Okay, now I need the u1. So this will be like previous u1 multiply u plus. Now here my j is actually 3. 3 minus 1 is 2. So this is u plus 2. Okay, so this way I have computed u1. And finally, before moving to the next iteration, I will be saying j plus plus so that I can fetch this minus 1 in the next iteration. Okay, so this way my whole formula will be applied, and finally inside this y I will be getting my final answer, that is y of 1925. Okay, so this way this pseudocode is working. So I hope you have understood that how this pseudocode is working. Actually everything is just similar to the Newton forward interpolation method. If you have just gone through that Newton forward interpolation method and you have understood that thing, then this backward interpolation method is also very easy. Okay, so now let's run this program in our VS Code and see what is the answer. So this is our code. So here you can see I have declared all the variables. Now I am first asking the user about how many number of terms that it want to enter. Then I have declared a array. Now this array is of size n plus 1. Okay, and after that I have asked the user to enter the value of x, enter the value of y. Okay, and finally what is the value of the x for which it want to compute y. Now the next thing, as you can see, it is the construction of the difference table, the same code that we have discussed, and I have just printed the difference table just for the better readability. Now after printing this difference table, this is the application of the formula. So here first I have computed the value of the u, then y, then u1. In fact they are initialized. Okay, j is starting from 2. Then this is the same loop that I have just explained. This is applying the formula or computing the terms of the formula again and again. Okay, finally I am computing or I am printing the value of the y, okay, for the corresponding value of the x. I have written this j so that the trailing values of the floating point number can be ignored. For example, I am getting 73.0, so I should just print 73. Okay, you can just write f also here. So let's run this program, and it is asking for the number of terms. So number of terms are 5. Okay, now let's enter the value of the x. Now let's enter the value of y. So after this, let's enter the value of x. So I want to find the population at 1925. Okay, so here you can see, let me enlarge it and let's see. So after entering all these values, the difference table is this one. Okay, here you can see this 8 minus 4 minus 1 minus 3, these are the same value that we have seen, okay, during our working example. So value at x equal to 1925 is 96.836800. So this is the population. Okay, so this is the same that we have seen during our working example. So we have got the correct answer or the correct population. Okay, so you can try this code for the another values of the x and y. Okay, so I hope you have understood this method. So if you have any comment, query, suggestion regarding this question, you can write down into the comment box and I will answer them. And if you want to know more about other numerical methods like bisection, regular falsi, Newton-Raphson, Gauss elimination, and other methods, you can find those methods in the numerical method playlist. The link of that numerical method playlist is in the description below, and the code of all these methods you can also find on the GitHub. So the link of the code you can find in the video description of each of these videos. Okay, please like and share this video and do subscribe this channel and press the bell icon for further notification. You can find videos on the interview experiences, interview questions, C programming, MCQs on my channel, so do watch them. So this is all about this video. So thank you. Goodbye.